On 9-7 day 2, the stuff that we went through on Friday, all those identities that I gave you guys, all are in play. So the reciprocal identities that I gave you guys, which you used a little bit on Friday, the tangent and cotangent ones, which I don't know if you noticed that or realized that, we never even used those two on Friday, but you will today. And then the Pythagorean ones, which we used exclusively on Friday. Okay, so that's kind of those things. If you look at the chart on 5:14, just so that you guys know, cofunction and negative angle identities are ones that we are not going to go through. I'm only going to give you the top half of that chart, not the bottom half. So just so that you guys are aware of it, we're only doing reciprocal, tangent, cotangent, and Pythagorean. We are not doing any of the other ones, just those three types. Okay? So the same things that I gave you guys on Friday with the reciprocal ones, the cotangent, tangent, and the Pythagorean identities are all still in play. Okay? Do you want me to write those down again? Okay? If not, you should have them in your notes. Anyway, here's what they're going to ask you to do for today's stuff. We're going to ask you to simplify the expression. So here's what it's going to look like. It's going to say the sine of x, cotangent x, secant x. And what we want to do is we want to try to simplify that down to as much as possible. So, what operation's being done between all three of them? Multiplication. If there isn't a sign there, it's understood to be multiplication. Now the sign I'm not going to change, but look at the things I gave you Friday. Was cotangent equal to something? Cosine over sine. Right. So what I'm going to do is I'm going to replace this with cosine of x over the sine of x. Okay, so what I'm doing is I'm using substitution, and I'm taking out those and I'm replacing it with something that it does equal. How about secant? What's the reciprocal of secant? Cosine. So now I'm going to replace this with 1 over the cosine. So what I did was I took the cotangent and the secant and replaced them with what they were equal to based on reciprocal or based on the cotangent or tangent function. Now, if it's being multiplied, if something's on the top that matches something on the bottom, what happens? They cancel out. This sign, by the way, is over 1. That sine of x cancels with that sine of x. What else can cancel? The cosine over cosine. And what do I have left? 1. And my answer is 1. This is what you're going to be doing for the majority of your assignment today is rewriting stuff, taking stuff out, putting new things in, and then trying to cancel out what you can. Okay? A little bit different than Fridays for sure. Let's see here. Let's go. Okay. Again, we are just going to simplify this down as much as possible. Are they always going to equal the number 1, by the way? No. They're just going to, that was just that first one. So, first thing that I want you to identify with this is how many terms are there for this one? 2. There's only 2 terms. This is one whole term, and this is one whole term. Remember, terms are always separated by adding and subtracting, not multiplying. So, from the front term to the back term, what do they share in common? Secant. If I take a secant out using my factoring techniques, what would I have left? The tangent squared theta plus, if I have a secant and I take a secant out, what do I have to have there to hold the spot? A 1. Good. Now, looking at our different ones that we had, looking at the things I gave you on Friday, is there one that has the tangent squared theta plus 1? Yeah. Zach, what was it equal to? So that secant didn't change, but this whole thing, according to what Zach said it was equal to the secant squared. So what I did was, I used the identities that we had, just tried to use the match. Zach found a match, so I replaced it. Now if you take a secant times by 2 secants, how many do you have? 3. So you have the secant cubed theta. That's as simple as we can get it. It's not going to equal a number all the time. It might equal something like that. What do you think? Where did I get that? From the Pythagorean identity. One of the Pythagorean identities, Tamara said 1 plus the tangent squared theta equals secant squared theta. Let's see. Probably about it.
And then she stopped. Like, I was like, where did she go? And she just stops. And I was like,
Okay, the last type that you're going to see is you're going to be given this, and I'm already giving you the answer. Okay, so the left side is saying what we have. We have the secant squared theta minus 1 divided by the secant squared theta is going to be equal to the sine squared of theta. That's the answer. What you have to do is show the work and how to get that. You can't just tell me the answer is sine squared theta, because guess what? It's already in the problem. Okay? So you have to actually verify that that works. So, first thing that I'm going to do is when you have multiple terms on the top, I'm going to split the top up. Or secant squared theta minus 1. As soon as you see the 1 in there, think Pythagorean identities. Okay? Was secant in there? Or secant squared? The Pythagorean identity that was close to that said 1 plus the tangent squared of theta equals the secant squared of theta. Correct? That's the one we just used that Zach just mentioned. What if we take the 1 and subtract it over to the other side? Is that a possibility? Yeah. If you do that, then you have the tangent squared of theta equals the secant squared of theta minus 1. Does this match this? Yeah. So then what I'm going to do is I'm going to take that whole big stuff out and replace it with what? The tangent squared theta, right? Over the secant squared of theta. What was the tangent equal to, according to the cotangent and tangent identities that I gave you? Sine over cosine. So what I'm going to do is I'm going to replace that with the sine squared of theta over the cosine squared of theta. And what's the secant according to the reciprocal identity? 1 over cosine. And I'm going to have squared there because they're all squared still. Now, from here, you guys have done this quite a bit lately. If you have a fraction divided by a fraction, how do you get rid of the bottom? Times it by the reciprocal. If you times this by the reciprocal of 1 over the cosine is cosine over 1. And what happens with the cosines? They cancel, leaving you what? Just the sine squared of theta. Which is what you knew the answer was supposed to be. We just verified that it worked. So for some of your problems today, they're going to ask you to verify that it worked. All you have to do is use that substitution. Okay? If you notice, that's what I did. I used a whole lot of substitution and I canceled out things to show what it equals. It's already giving you the answer. So you just telling me that the answer is sine squared theta, great for you. You can copy it out of the book. But showing me how it gets there is how to do these problems today. Again, you're using substitution. Use the 3 different types of identities that I gave you. Take out what you can, cross out what you can, and see what's left over when you get done. Okay? Would you like me to do another one?
No.
Yeah? Okay. Okay, so we're going to verify. What's the answer going to be in the end? 1. Okay, that's what we want to try to do. Now, anytime, what I try to do is I try to get it back to sines and cosines, so that way they kind of get back to the original part. Do you see where it says cosecant and secant in the bottom? What's the reciprocal of cosecant? 1 over the sine. And what's the reciprocal of the secant? 1 over the cosine. How do you get rid of a fraction on the bottom like that? What's the reciprocal of 1 over sine? Sine over 1. And if you do something to the bottom, then you got to do it to the top. So what's sine of x times the sine of x? Huh? Sine squared x. For the top. The bottoms, yes, Sierra, cancel. But not the tops. What's the reciprocal of 1 over the cosine? Cosine over 1. The bottoms will cancel. And what is cosine times cosine? Yep. Is that one of your identities that we have? Looking back at what I gave you on Friday, which one is it? It's the Pythagorean one, and it's the very first Pythagorean one, isn't it? So sine squared x plus cosine squared of x equals 1, and 1 does equal 1. Good job. Yes, Bert. Because I'm not squaring the angle. Because we're dealing with like triangles and stuff like that. We're not going to square an angle. We're going to square the operation. Because if you square the angle, then you're going to get an angle bigger than 180, typically.
Well, I was supposed to get it, but it was 20. Okay, so let's check.
Okay, what do you think?
It was 20.
We'll see.
That's how I
Around?
Yeah. So
Oh,
then
you're getting it.
yeah.
So anyway, we're on page 517, 11, 12, 14, 23, 24, and 29.